Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and let's jump right into today's lesson. Don't forget to put your first and last name in the top right-hand corner of your paper, followed by the period and the date. Today we'll be doing Unit 2, Lesson 2. The topic is Piecewise Functions, Part 2. And our objective today is I will graph piecewise functions by identifying key features of each function. So before we jump into piecewise functions, I want to review slope. So we have 4 types of slope. Those 4 types of slope are positive, negative, no slope, and undefined. So let's talk a little bit about each type of slope. So a positive slope happens when you have m equals a number, and that number is greater than 0. All positive numbers are greater than 0. So as long as m equals a positive number, a positive slope is going to look something like this, where we rise to the right and fall to the left. Positive slope always makes a line, rise to the right and fall to the left. All right. Negative slope, on the other hand, happens when m equals a number, and that number is negative, which means that number is less than 0 this time. So if that number is less than 0, that means that it's negative. And a negative slope has a line that rises to the left and falls to the right. So negative slope always looks like this. It rises to the far left, but it falls to the far right. Then we can also have lines that have no slope. And no slope is the same as 0 slope. And this happens if m is equal to 0. No slope happens when you have a when you have a run, but you don't have a rise. So this happens when you have 0 for your, I think I said that backwards, I'm sorry. A 0 for your rise, and some number for your run. So what happens is 0 divided by a number is always 0. So your slope is 0. This means that there's no rise, but there's still a run. So what does that look like? Well, let's say our line started at y is 2, and we have no rise. So we don't go up, we can't go up, but we can run. And I'm gonna run to the right 1. I'm gonna run to the right 1. I'm gonna run to the right 1. So that would mean that my slope is m equals 0 over 1. So I'm not rising, but I'm still running. And then if you draw that line in, what you see is a horizontal line. So m equals 0 will always be a horizontal line. And those lines will always have an equation that looks like y equals k. K being some number. So y equals k, and k just represents some number k. And we'll talk more about that in just a second in example 1. Let's talk about undefined slope before we move on. Undefined slope happens when you have a rise, but you don't have a run. So if your slope is undefined, you just say m is undefined. And this happens if you have m equals a number divided by 0, which means that you have a rise, but you don't have a run. Well, are you allowed to divide a number by 0? No. You can't divide something by nothing. That's impossible. So we say that this fraction, anytime you have a fraction with 0 in the denominator, is simply undefined. So our slope is therefore undefined. So what happens is, let's say that we start, let's start at an x value of 3. And I have an undefined slope, which means that, let's say I have m equals, let's say 3 over 0. Well, this is an undefined fraction, so you're never going to write m equals 3 over 0 as an answer. But let's just use it to understand what happens with this line. Well, this means that I have a rise of 3. So I'm going to rise 1, 2, 3, but I have 0 run. So I don't go to the right at all. Then I'm going to rise 3 one more time. 1, 2, 3. And there's no run. Well, what do I end up making? I end up making a straight line that's up and down, which is a vertical line. So anytime you have an undefined slope, I'm going to erase that because we don't want to write fractions with 0 on the denominator. What happens then is m is undefined, so we end up with a vertical line. And vertical lines always have an equation that looks like x equals some number. So as you can see with our horizontal and our vertical line, in our horizontal line y equals k, there is no x because the slope was 0, so x just dropped out. For x equals h, there is no y. So we don't have to worry about any y values, we're just worried about x equals some number. Okay, so let's talk about what that means when we are graphing an actual equation that looks like the form y equals k and x equals h. Well, if you look at example 1, first off, we have an equation that looks like y equals -2. So this is y equals some number k. Well, this reminds me of y equals k, which means I'm going to have a horizontal line. So I know that this is going to be a horizontal line at y equals -2. Well, if I wanted to make a table of values for this, let's make a table. And for my x values, I want like -3, -2, 0, 2, and 3. Well, what is y equal to? Well, my equation says that y equals -2. That means that no matter what x is, y is -2. So if x is -3, y is still -2. If x is -2, y is -2. If x is 0, y is still -2. If x is 2, I bet you guessed it, y is -2. If x is 3, well, hey, y is still -2. So what I see here is that no matter what x is, y is always equal to -2. So let's plot those points. Well, -3, -2 is here. -2, -2, 0, -2, 2, -2, and 3, -2. And I have these lines, these points that are creating this horizontal line. So I'm going to draw my horizontal line through them. And there I go. And I have a horizontal line. Where does that horizontal line hit the y-axis? Exactly at -2. I meant to do that with a highlighter. Exactly at y equals -2. Well, what was y equal to in this line? -2. So there we go. We've just graphed a horizontal line at y equals -2. This is the graph of the equation y equals -2. Now let's do part B together. So part B, I have x equals some number this time. I have x equals h, some number h. Well, in my types of slope in my notes up here, x equals h will always create a vertical line. So I know that I need to create a vertical line this time. And let's see if we can figure out what that vertical line is going to look like. Well, let's make a table, just like we did before. And this time for our table, we already know that x is equal to 2. So we need some y values. Well, for my y values, let's do like -3, -2, 0, 2, and 3. So when y is -3, what would x be? Well, x, for this equation, x can only equal 2. So that means that if y is -3, x is 2. If y is -2, x is 2. If y is 0, x is 2. If y is 2, x is 2. If y is 3, x is still, you guessed it, 2. Is x equals 2 a function? This isn't a function, right? How many different outputs does 2 have? Well, according to our table, 2 has at a minimum of 5 outputs. But there's really infinite points on this line, so 2 would have infinite an infinite amount of outputs. Definitely not a function. That's okay, we can still graph it. So let's graph 2, -3, 2, -2, 2, 0, 2, 2, and 2, 3. And you should notice that those points are creating a vertical line that goes up and down. So why don't you give it a shot? Go ahead and do part C and part D without me. Graph the line y = 0 for part C, and then graph the line x = -4.5 for part D. Press pause and then press play when you're ready to check your work. All right, so hopefully your graphs look just like mine. When you graphed y = 0, no matter what the x values are, y is 0. So when x is 5, y is 0. When x is 1, y is 0. When x is 0, y is 0. When x is -3, y is 0. And you start to notice that all of those points end up being on the x-axis. So y = 0 is actually the same thing as the x-axis. So you should have a horizontal line overlapping the x-axis. For part D, x = -4.5. Remember, no matter what y is, x is always -4.5. When y is 5, x is -4.5. When y is 1, x is -4.5. When y is -4, x is -4.5. And you should see those points then creating a vertical line going through the x-axis at -4.5. I hope you got the same answers as me. Good work, guys. Let's move on. So now we're going to graph some piecewise functions again. So in example 2, part A and part B, we're going to graph a piecewise function. So remember, a piecewise function always has f of x equal to, and then you've got the squiggly, and then you've got at least 2 rules within that function. Well, on Monday and Tuesday's lesson, we focused on piecewise functions that only had 2 rules. Today, we're going to do piecewise functions that have 3 rules. So there's going to be 3 different pieces on our graph. The good news is we're going to follow the same set of steps that we used in Monday and Tuesday's notes. So this time though, instead of only having to find endpoints for 2 rules, we have to do it for 3. So in this function, the first rule we have is f of x is equal to -4 when x is less than or equal to -2. The second function is f of x is equal to x minus 2 when x is between -2 and 2. Then our third rule is f of x is equal to -2x plus 4 when x is greater than or equal to 2. So let's go about finding our graphs. F of x equals -4 for x is less than or equal to -2. Well, remember, f of x is interchangeable with y. So we could write this as y equals -4. Well, hey, we just learned that y equals -4 means that we're going to have a horizontal line. But we want a horizontal line when x is less than or equal to -2. So let's find our first endpoint. Well, I don't have to plug in x equals -2 because there's no x in this equation. It only has a y. So that means that my x value is going to be -2. And then for this equation, what is y always equal to? Right, -4. So our endpoint is at -2, -4. So let's go to -2, -4 on the graph. And it looks like I need to label this graph. I'm going to do that real quick. Now that my graph is labeled, I'm ready to actually graph this endpoint. So let's graph -2, -4 would be down here. And it is a closed circle since x is less than or equal to -2. So it's a closed circle on -2, -4. And then it would normally be this horizontal line. that would go through that point, because no matter what x is, y is always -4. Well, we only want, though, the part of the line that is less than or equal to -2. So -2, everything that's less than -2 is off to the right. So the only portion of this line I want is this horizontal line that goes off to the right. And since x is less than or equal to -2, there's only one restriction. I want to make sure I have an arrow at the end of that ray, so I know that it extends in that direction forever. All right, let's move on to the second part. So the second function is f of x equals x minus 2 when x is greater than -2, but less than +2. So we have two endpoints we have to find here. We have an endpoint we need to find for -2 and +2, when x is -2 and +2. So what we're going to do is, and I'm going to do my work down here. What we're going to do is we're going to plug in x equals -2 and then x equals +2 into that rule. So we're going to find, remember, f of x is interchangeable with y, so y equals x minus 2. So the first one we're going to plug in is -2. Y equals -4. So I have an endpoint at -2, -4. Now notice x is greater than at -2. It's not equal to. So that means that we're going to have an open circle on that point. Now let's do the same for +2. So y equals 2 minus 2. So y is 0. So we have the point 2, 0. And again, x is less than 2, which means we have an open circle on that point. So let's plot those 2 points. So -2, -4. Okay, we're already on that point. And because that point was in fact closed for the other -2, -4, we're going to leave it closed because it is included based on the other piece of our piecewise function. Then we're also going to plot the point 2, 0, which is right here. Oh, just kidding. That was supposed to be an open circle, huh? And then we need the line between those 2 points. Wait, I was supposed to plot 2, 0, and I just plotted 0, 2. Hey, I caught it before I published the video. That's good news. So we're gonna put an open circle on 2, 0, which is right there. I'm silly, I put it at 0, 2. Sorry for the confusion. So what's the slope of this line? If you look at the rule, f of x equals x minus 2, our slope is whatever's being multiplied by x. So my slope for this line would be m equals a +1, because it's technically 1x. So my slope, I'm going to start at the lower point. I would go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Cool. And I end up at my end point. I'm just going to draw a line between them. There we go. We've graphed the second rule in our piecewise function. Now let's do the third one. So the third rule was f of x equals -2x plus 4, but only when x is greater than or equal to 2. So we're going to find our endpoint. And the x value we're going to use for this endpoint is 2. Let's plug that into our function. So f of x is equal to -2. Hang on. I'm going to rewrite this as y, actually. So -2 times 2 plus 4. So y is equal to -4 plus 4. Y is equal to 0. So our end point is at 2, 0. Now, let's think about if that's going to be open or closed. Well, x is greater than or equal to, there's the equal to part, so I know that I'm going to have a closed circle on that point. And my slope is -2, so m equals -2. So let's plot that point. So 2, 0 is right here. Now for the second function, that was an open circle, but because it's a closed circle for the third function that we're graphing, we are going to go ahead and fill that in because it's included in this third piece. So we know that it's included in our original piecewise function. Now let's use our slope to find the rest of the points on this line. Now remember, we want x is greater than or equal to 2. Well, x is 2 along right here, right? This is x is 2. Well, x is greater than 2 to the right of 2. So I know that I need to go towards the right with this ray. So to do that, I'm going to go from my starting point at 2, 0. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And that's a -2 slope. And I put an arrow at the end of the ray, so that tells me that this graph does extend forever in that direction off towards the right. Now I'm going to erase these yellow markings because I don't need them. And this is the graph of our piecewise function. And as you can see, it has 3 parts. So part 1, f of x equals -4 for x is less than or equal to -2 is right here. F of x equals x minus 2 for x is greater than -2 but less than 2 is this piece right here. And f of x equals -2x plus 4 for x is greater than or equal to 2 is this portion here. So now let's try to graph a piecewise function that has 3 rules on your own. So example B for part 3 here, or part B of example 3, is here for you to do on your own. You're going to graph f of x equals x if x is greater than or equal to 2, f of x equals 5 if -3 is less than x is less than 2, and 3x plus 2 if x is less than or equal to -3. Pause the video, give it a shot on your own, and then press play when you're ready to check your work. Go for it. Good luck. All right, here's my graph of this piecewise function. So as you can see, I've color-coded it for us. The first piece of this piecewise function is f of x equals x if x is greater than or equal to 2. I did my work for the endpoint over here. And then this is the piece of that graph. I put an arrow at the end of that ray so I would know that it extends forever. For the middle function, f of x equals 5 if x is between -3 and 2. I've got my work for that up here. I've got open circles and the line filled in between. Then for the third piece, f of x equals 3x plus 2 if x is less than or equal to -3. I've got my work for that right here. And then my graph is this piece down here. So there you go. And as you can see, because I went to -3, -7, I did count, I ended up changing this to count by 2s on my y-axis. So -3, -7 is this point. And then I went down 1, 2, 3 over 1, down 1, 2, 3 over 1. And then drew in my line. So there you go. All right, go ahead and get started on your homework, and I'll see you back in class. Have a good day.